Very good morning, students. So let us continue the random variable chapter. As I had mentioned earlier, so far we have completed 95% of the syllabus. Now this is the last concept which we have from random variable concept, which is bivariate probability distribution concept. So let us continue that now. Look at here the example. From the following joint probability distribution, find the coefficient of correlation and also find expectation of x plus y. So bivariate, I mean nothing but joint probability distribution. It is mentioned given. It is mentioned below. So we need to calculate the correlation coefficient gamma. You know the formula of gamma correlation coefficient. Covariance of xy divided by square root of variance of x into square root of variance of y. So you might have seen the formula correlation coefficient, and also find expectation of x plus y. As we know the addition theorem of expectation of x plus y is nothing but expectation of x plus expectation of y. Then look at this problem now. So look at here, x y, so joint probability it is given. So the real values of x are -1 0 1, the real values of y are -1 0 1. These are the real values, guys. These and these are the real values, and these are the probability values of such joint function. -1 that joint probability function is 0.1 between x1 y1. Clear? And next, y1 x2 is 0, so this cell is 0, the probability value. See, you all know that the total probability is always equals to 1. See here, the 1 you can see, the total probability. Am I clear? Now this is the table given. Now using this table we need to find the correlation coefficient. To calculate the correlation coefficient we need to observe covariance of x comma y, that is the first value, and then variance of x, variance of y. We need those three terms, then only we can calculate correlation coefficient. At the same time, expectation of x and expectation of y. You know the meaning of expectation of x, nothing but mean in terms of expectations. We say expectation of x is nothing but a mean of x, and expectation of y is nothing but mean of y. Let us see the problem. And as you know the definition, right, joint probability, the p of x comma y is nothing but probability of capital X takes the real value small x, and then capital Y take the real values small y. Then that function we call it as a joint probability distribution. Am I clear? So here we consider the bivariate, two variables x and y, two random variables we have to consider it along with concerned probabilities p of x and p of y. Then the probability, the joint function, probability of x comma y, we call it as a joint probability distribution. So another name of joint probability distribution is bivariate distribution, also we can say bivariate probability distribution. Now marginal probability distributions. Let us see here marginal probability distributions. You can see these two tables, right? Look at here, marginal probability distribution of x and y are. See here, these are the x real values -1 0 and 1, and these -1 0 1, what are the totals? 0.2 0.4 0.5. So generally these totals are of rows, right? Rows totals and then column totals. These are all rows total and these are all column totals. So for this marginal function of x -1 0 1 with concerned probability we get 0.2 0.4 0.4, the totals of this one columns. And then marginal function of y for rows, column totals, just look at that, 0.2 0.6 and 0.2. those are all marginal function of y. Now you know the expectation of x. Expectation of x means x into p of x, the total sum of x into p of x. So this -1 into 0.2, 0 into 0.4 plus 1 into 0.4, adding all together you get the value. Expectation of x is 0.2. And then expectation of x square is nothing but summation of x square into p of x. Summation of x square into p of x. See here, look at here, square of x. So minus 1 square into 0.2 plus 0 square into 0.4 plus 1 square into 0.4. So you'll be getting expectation of x square. And then, so expectation of x we got already, the mean of x. Similarly, mean of y you calculate, because in the question what it is asked, expectation of x plus y. So why we calculate the variance? Because we need to calculate the correlation coefficient, guys. What is correlation coefficient formula? Gamma. Covariance of x comma y divided by square root of variance of x into variance of y. Just go through the previous formula which I gave in the previous video. I mean earlier videos which had been sent. In those videos I have explained about the formula of correlation coefficient gamma. Covariance of xy divided by square root of product of variance of x into variance of y. So again covariance of xy is nothing but expectation of xy minus expectation of x into expectation of y. So to calculate the covariance, I mean correlation coefficient, we need covariance. To calculate the correlation coefficient, we need even variances. So let us see the formula in terms of expectations, variance formula. So variance of x equals to expectation of x square minus expectation of x whole square. So substitute that one, you will be getting 0.56, and the standard deviation you got the value 0.7483. Similarly, y you do it, marginal function of y. Same, expectation of y square, as well as variance of y and standard deviation of y. See here expectation of xy, what is the formula? Double summation x into y into p of x comma y. This how to calculate. Guys, do you remember the bivariate problem, which is a bivariate correlation and regression concept we calculated, the big table problem? You might be remembering that. So how we calculated there, x into y into fxy? The same way, x into y into, here instead of frequency terms, probability terms were there. Just look at this table now. How to calculate that expectation of xy? See here, minus 1 into, just look at the cursor there, minus 1 into 0.1 plus minus 1 into 0 plus minus 1 into 1 into 0.1. That becomes the total, right? That becomes the, see here, first value, minus 1 into 0.01 plus. So like that entire thing if you calculate, you get the expectation of xy is 0.1. See here, we have learnt in correlation as well as regression concept, double summation x into y into f of xy. There instead of f, here probability terms were there, p of xy. The same logic. So calculate that one. And then substitute this expectation of xy in covariance. I said no formula, expectation of xy minus expectation of x into expectation of y, that equals to 0.1 minus, already these two you calculated, expectation of x and expectation of y. Substitute the here, you'll be getting 0.1. And I said the covariance xy by square root of variance of x into variance of y. Square root of variance is nothing but standard deviation. So directly here they have taken standard deviation. Then you understand that why we calculated standard deviation of x and standard deviation of y. Are you clear, guys? So now look at this, gamma, covariance of xy by square root of variance of x, nothing but standard deviation of x, into square root of variance of y, nothing but standard deviation of y. That equals to, after substituting, you will be getting the value 0.2113. Calculate that. Therefore expectation of x plus y minus expectation of x plus expectation of y is 0.2. So these two questions only they have asked. Guys, are you clear about this question? Just once again have a look. Very simple question. Only the thing is, table, you have to divide the marginal function of x by using this table. X the minus 101 with the totals, and then y minus 101 with these totals. So divide that in marginal function, marginal probability distributions x and y. Using this you can calculate expectation of x, expectation of x square, and expectation of y and expectation of y square, and then variance of x and variance of y, standard deviation of x and standard deviation of y, and then expectation of xy, -1 into 0.01 plus -1 into 0 into 0 plus -1 into 1 into 0.1 plus 0 into -1 into 0.1 plus 0 into 0 into 0.3 plus 0 into 1 into 0.2 plus 1 into -1 into 0 plus 1 into 0 into 0.1 plus 1 into 1 into 0.1. So the same way of calculation we have seen in correlation and regression concept. If you remember, double summation x y fxy, if you remember that, instead of frequencies here we observe probabilities. That's it. That is only the difference. Hope I am clear this problem. Try to calculate this one, guys. This is the last concept which I said in the previous video, that 5% syllabus is still remaining. So this is a concept. Are you clear, guys? So look at this one more problem. What it is asked: find the value of k. Again, probability distribution, bivariate distribution is given. Find the value of k and expectation of 3x plus 2y and correlation coefficient gamma we need to calculate. Again, table is given, but here in the table somewhere one missing term is there, k. So you know how to calculate k, the total probability, these values, 0.1 plus 0.1 plus 0.05 plus 0.1 plus 0.2 plus 0.15 plus 0.1 plus 0.2 plus k. The total probability is always equals to 1. Equate this whole total equal to 1, then you will be getting k. Right? After getting the k value, again divide the marginal function of x, 246 and these totals, row totals, and 139 and column totals. These are the marginal function of 246 with these totals are marginal function of x, 139 with the column totals were marginal function of y. Clear? Again same, expectation of x we need, expectation of y we need, and then we need to calculate k first. K means the total. First find out the k. Adding all those, you'll be equating to 1 and k value will be getting 0, it seems. Afterwards, marginal function of x, using that find expectation of x, expression of x square, variance of x, standard deviation of x. So here standard deviation is not needed because directly the variance of x we calculated. Similarly, marginal function of y, expression of y square, as well as expectation of variance of y, and then see we calculated both the standard deviations. If you calculate standard deviation also fine. If you do not calculate also, directly this square root of variance in the formula of correlation coefficient you can substitute. There is no issue. Again, expectation of xy, double summation x into y into p of xy. You know that x into y into p of xy, just like a correlation concept, the big problem. Substitute this value in the covariance formula. You will be getting covariance value. So once we get the covariance, already we calculated the variances. By substituting all, you will be getting correlation coefficient value. Are you clear? So this is the formula. Look at here. Instead of standard deviation of x, you can write it as square root of variance of x. Square root of variance is nothing but a standard deviation, guys. There is no confusion at all here. So this is in the form of expectation of ax plus expectation of by. So expectation of ax means a into expectation of x. Here b into expectation of y. Similarly, substitute the expectations of y, x and y, you get the value this. So that's the end of random variable concept. 100%, it is totally done, which has been reduced in the PU-1 syllabus, that 30% reduced syllabus. Now it is totally 100 on 100% completed. Am I clear, guys? So these are all the videos from the random variable chapter. Hope you thoroughly observed all the videos from the probability concept. Once again, I stress upon probability and random variable chapter. Don't be under the impression that in first PUC is already, as a board says, we all have passed and these two chapters, why to take tension so much? No, don't take it light, guys. I said you, this probability and random variable chapter, in two ways it will be helping you in second PU. One is in mathematics, probability with random variable concept. Second is in statistics, theoretical distribution chapter, which is very typical and important chapter from your second PUC. In that chapter, these probability terms calculating using those random variable, everything again we'll be observing in PU2. So these two chapters are very important, crucial chapters. So among your first PUC concepts, according to my knowledge, how the central tendency and bivariate, I mean univariate and bivariate are important. Same way, equally the equal weightage probability and random variable also is having. So such an important chapters, these 4 chapters actually. Luckily for the final examination, these got reduced, I mean these got deleted, blown up, but these chapters are very much useful in coming second PUC concepts as well as in mathematics also. Am I clear, guys? So hope you are following all the videos. Kindly watch how the probability videos you have watched, the same way even you too watch these videos from random variables. So hope you are enjoying the videos, and then try to understand. If you have any queries, anyhow soon we are going to start offline classes. Let us meet in the class. If you want, we can glance off all these things which has been completed through YouTube videos. So with this, I'm going to put a complete full stop for PU1 syllabus. So completely 100 on 100% it is completed now, your whole syllabus, right? So only the thing is, I have completed my 100% syllabus teaching, but you should complete your 100% practicing and 100% reading, learning those chapters. That is your bounden duty to do it at home during this pandemic situation. Okay guys, so let us meet as early in the regular offline classes. Hope by next month everything will set right, everything will be normal, and we will meet in the regular classes itself. So enjoy the videos, take care of yourself and your health and your family's health also, right? So don't go anywhere, stay at home, right? So with this, I'm going to put full stop for this random variable chapter. So once again, thank you so much for cooperating and supporting well from the beginning in all the ways, staying at home, listening all the videos, listening all the live classes, so everything. So you are doing your best, that's it. So keep doing like this. Am I clear, guys? So take care of your health. Thank you once again. Signing off, your Charan sir. Take care. Bye.